Real exam questions. This is question 44. It's about strut and ties with deep beams. Determine the reinforcement in the deep beam with thickness 300 millimeters. The wall is loaded at the top with a line load of 400 kilonewton per meter in ULS persistent, excluding the wall's own weight. You do not need to check the nodes. The concrete quality is 30 megapascal, the steel quality 500, and make a sketch of the reinforcement. So this is a deep beam, or we suppose it's a deep beam. We will check that first. And when with a deep beam, the compression strut is taken at a position which is 1/4 of the total width of the beam. So we are concentrating our loads into those two struts. Then from a certain level Z, they will find the supports of the deep beam, and this will be in equilibrium with a tension rod, which is T, and under an angle theta. And of course, because those two compression struts are coming together, you have another compression strut there. The point where the vertical compression strut goes to the support is Z, and the point of gravity of the tension rod is C. The L that you have to take into account is of course the total width L minus 2 times half of the width of the support, which was 0.3 meter. C, you can estimate C as 0.075 times the length L, which gives you 20 centimeters. Now, can we use the deep beam theory for this? The length L must be smaller than 3 times the h, which is the case, so we can use it. But L is smaller than h, so for the deep beam theory, it means that Z equals 0.6 times L, or 1.62 meters. The tangens of this angle then is of course the Z value, which is 1.62, divided by this piece, which is of course the distance from there to there, which is 3/4, minus half the support width, and it gives you tangens theta 2.7. But there is a limit on it, and the limit of the angle of the strut is tangens theta 2.5. Now, this is now what we got. You will see that normally the Z, because this angle changed, you should think that this Z is changed, but in fact the tangens theta limiting to 2.5 means that we give a minimum tension in the tension rod. So the tangens theta 2.5 is needed for calculating T, not needed to estimate where those compression rods are diverging. The total load in ULSP is then equal to 400 plus the dead weight of the proper weight of the deep beam, which is 1.35 times the depth times 1.4 times 20 times 5.4 times 25 gives you 455 kilonewton per meter. So everything is expressed by kilonewton per meter. The total load P is then the load per meter times 1.5, because this is coming to P, and it's 682.5 kilonewton. And then the tension is P divided by the tangens theta, but with an with a minimum of 2.5, so that's why we use 2.5, and it's 273 kilonewton. The reinforcement is then the total tension divided by the yield stress of the reinforcement, and it gives you 628 square millimeters. And this is 2 diameters 20. The minimum reinforcement of a deep beam is 0.1% in all directions, which gives you, for a wall thickness of 300 millimeters, gives you then 300 square millimeters per meter. Or this is 4 diameters 10 per meter, is 314, so that's close enough. So now we make a sketch of the deep beam. On the bottom, we put the tension reinforcement of 2 diameters 20. Then front and back of the deep beam will have reinforcement of diameter 10 every 250 millimeters, horizontally and vertically. And of course, at the end of the wall, we will put U-shaped steel bars with the same diameter and on all sides.